Hello friends, so today we are going to start with the next question of EJU, which is 2011 session 1 part 3 M10. So let's begin. So first of all we'll discuss the question and see the question first. So this is the question. It says let a be a constant. Consider the quadratic function in x. Y is equal to 2x square plus ax plus 3. So here this is the equation number 1. Suppose that the vertex of the graph of equation 1 in the first upper right hand quadrant means it want to say that x is positive and y is also positive because they are on the upper right hand quadrant, which is 0 to 90 degree. So the range of the values of a can take is, so here we have to find the values of range of a. For finding the range of a, we need to find the discriminant of this equation. So we'll find the discriminant of this equation. So next, and at least the integer a satisfying the inequality is ef. So here we are to find the least integer which satisfies this inequality. This inequality, least integer which satisfy, means here it is in root. So we are to find here integer a, least integer satisfying this inequality. So let a is equal to ef in equation number 1. So y is equal to 2x square plus px plus q is the next equation. Be the equation of the graph which is obtained by translating the graph of 1 by minus 1 by n in the direction of x by n by 6 by n square in the y direction. So it wants to say that in the translating the graph question, first we'll translate the graph by changing the values. So how we'll change the values, we'll see in the question. So here is the value of p and q. The total number of natural number n for which p 2 into is an integer is L. So here it is p. So we'll see that we'll put natural number here and obtain integers. P in 2 is an integer. So for finding p is equal to integer, we'll put different natural number and find the total number of natural number which we can put and get integer for p, and that will be L. Among these n, means suppose natural number comes out to be 4 or 3. So from those 3 natural numbers which we have got, now we'll put the values of those 3 natural numbers in q to get q an integer. Consider the ones that such that the value of q is also an integer. So for getting q an integer, we'll put those natural numbers inside q. Then m is the value of n, means we'll put the value of n to get q an integer. So that n, that natural number is the value of m, for which q takes the minimum value. So let's begin the question. So first of all we are given with the equation y is equal to 2x square plus ax plus 3. So for finding the range, we have decided that yet we'll go with a discriminant b square minus 4ac. D is equal to b square, which is a square minus 4 into a into c, a square minus 24. So we'll put the discriminant is equal to 0. A square minus 24 is equal to 0. A square is equal to 24. A is equal to plus minus 24, root 24. Or we can write root 24 as 2 root 6. So plus minus 2 root 6. So the range of a is minus 2 root 6 to plus 2 root 6, as it is plus minus. So we can also write it as minus 2 root 6 to 0 and 0 to plus 2 root 6. So according to the question, we require minus 2 root 6 to 0. So this is our A, B, C and D. So let's go to the next step. and the least integer a satisfying this inequality is. So this is saying that we have to find the least integer in this range. We have to find the least integer. Integers are the complete real numbers, then they can be negative, positive or 0. So root 24 cannot be written in the form of a real number, and root 16 can be. So this is the least integer in this range, -4. So EF is equal to A is equal to -4. A is equal to -4. So let's go ahead. So the next equation is given to us, y is equal to 2x square plus px plus q. Now be the equation of the graph which is obtained by translating the graph. This is the most important step of this question of translating the graph. How we have to translate the graph is -1 by n in the direction of x. So -1 by n will go in the rightward direction, means -1 by n will go here, and x plus 1 by n it will become 6 by n square in the direction of y minus 6 by n square. So this is our equation, which is y is equal to 2x square plus ax plus 3. This was the first equation. So y will put the value of a here as we have got it. So y is equal to 2x square minus 4x plus 3. So in the place of y we are going to put y minus 6 by x square n square, and in the place of x we are going to put x plus 1 by n. Y minus 6 by n square is equal to 2 into x square, which was x. We are now going to put it as x plus 1 by n square minus 4 into x plus 1 by n plus 3. We have just put the equation of y and x in the first equation. So here we'll solve the square, x square plus 1 by n square plus 2x by n. So now by solving this we'll get y is equal to 2x square plus 4 upon n minus 4 x plus 8 by n square minus 8 by n plus 3. This is the equation we have got. So here our p is equal to 4 upon n, which is the coefficient of x, 4 upon n minus 4. So we have got our g and h, both are 4, as we can see in the question. Q is equal to 8 upon n square minus 4 upon n plus 3. So I is 8, j is 4 and k is 3. So now we'll go on with the cases. Now we'll read the question further. The total number of natural number n for which p in the equation 2 is an integer. So for finding p an integer, we'll put the different values of n. So first we put n as 1. So by putting n as 1 we got the value of p is 0, which is an integer, yes. So it is a true case. Case number 2, when n is equal to 2 for finding p an integer. So by putting the value of n is equal to 2 we get p is equal to -2. When we get p is equal to -2, it is an integer, it is a negative integer. Now third case is n is equal to 3. When we put n is equal to 3 in the equation of p, we get -8 upon 3 by doing the fraction portion solved. So next is n is equal to 4. So p comes out to be -3, which is again an integer. So there are three natural numbers which satisfy p is an integer, which is 1, 2 and 4. So L was the total number of natural number which satisfy p is equal to 3. So there are just 3 natural numbers which satisfy p an integer, 1, 2 and 3. There are 3 numbers, so L is equal to 3. So Q, now we are to apply this same on the Q. We have got our n, 1, 2 and 4. These are the 3 natural number by which we got p an integer. So the same we have to apply on the q, that we 3 this natural number we have to put in q to get an integer. So case 1, when n is equal to 1 we have to put in q. So by putting 1 in q we get q is equal to 7, which is an integer. By putting n is equal to 2 we get q is equal to 3, which is again an integer. So case 3 we put n is equal to 4. So by putting n is equal to 4 we get q as 5 upon 2, which is not an integer, it is a fraction number. So q is minimum at x is equal to 2. At n is equal to 2 the q is minimum, which is q is equal to 3. So our m is equal to 2 and n is equal to 3. So you can just check it out, all the answer which are written here. Thank you.